Right, this is a Pearson Edexcel paper. It's paper 2, foundation tier, and it's from 2021. It's worth 60 marks. Question 1. Figure 1 shows an electrical circuit. Draw a circuit diagram of the electrical circuit in figure 1 in the space below. Right, so we've got a battery up the top. So there's your symbol for your battery. Then it comes round into a switch. I'll do an open switch. And then it comes down into a lamp. So you can either draw a lamp like that, or you can draw a lamp like that. And then it just goes back to the battery. Nice easy 4 marks there. Question B. When the current in a lamp is 0.15 amps, so that's the current I, the resistance of the lamp is 40 ohms, so that's R. Calculate the voltage, so that is our target, across the lamp. And they've even gave us the equation, and we don't need to rearrange it, so we just need to pop the numbers in. And that comes out as 6.0 volts. C. Figure 2 shows an ammeter that can read up to 5 amps. State the value of the current shown on the ammeter in figure 2. Right, so going from 1 to 2, there are 10 little notches. So each notch, each division is 0.1. So that's 1.1234. 1.4 amps. Question 2. Figure 3 shows some objects and words describing these objects. Draw one line from each object to its description. Right, object. Nail in a current carrying coil. Is that non-magnetic, permanent magnet, or temporary magnet? That's a temporary magnet because you can turn the current on and off, and that'll turn the magnetism on and off. Plotting compass needle, that'll be a permanent magnet. You don't want it to become demagnetized while you're out in the fields, otherwise you'll get yourself lost. And a wooden ruler is non-magnetic. Remember, the only magnetic materials you can get are iron, steel, nickel, and cobalt. Part B. Figure 4 shows a wire passing through a piece of card. The wire carries an electric current. Draw one magnetic field line on figure 4 to show the shape of the magnetic field produced by the current. Right, what you're looking for is it's the right hand grip rule. So if you draw your fingers like that, and then your sort of thumb coming down here, the way the thumb points, that points which way the current's going, and the way that the fingers are curled round, that would show you which way the magnetic field's going. So I'm sorry, my picture is terrible. So you need to draw one circle going around that. And the next question says, draw one arrow on the field line you have drawn to show the direction of the magnetic field. So if you're looking down, it needs to be going clockwise. So your arrow is pointing that way. Question C. A student measures the strength of the magnetic field at different distances from the wire in figure 4. Figure 5 shows most of the student's results. Strength of the magnetic field up the side and distance from the wire in centimetres along the bottom. Figure 6 shows two extra sets of results. MT is a unit of strength of the magnetic field. That's millitesla. Distance from wire in centimetres, strength of magnetic field. And part 1 just says plot the two extra points on figure 5. And then part 2 says draw a best fit curve. Right, let's do that then. So when it's 1 centimetre, it needs to be 8.1 milliteslas. 1 centimetre, 8.1. Now there's 5 divisions in between 8 and 9, so each one is 0.2, and we want 8.1. So it's going to be in between the first 2 divisions. Right, distance from wire 2 centimetres, and it needs to be 3.9. So distance 2 centimetres and 3.9 will be right there. So we'll do our crisscross, so it's like that. And then we had to draw a line of best fit. So it's going to come all the way down like that. Let's see how steady my hand is. Coming down like that. That'll do. Part 3. Use the graph in figure 5 to calculate the change in strength of magnetic field when the distance from the wire changes from 4 to 8. So how much did the magnetic field change from 4 to 8? Right, well there's the distance at 4 and there's the distance at 8. So at 4 that was 2, and at 8 that was 1. So it's basically gone from 1 to 2, so the difference is 1. Part 4. The distance from the wire affects the strength of the magnetic field. State one other factor that affects the strength of the magnetic field. Well, the size of the current. More current equals stronger magnetism. Question 3. This question is about using the mains electricity supply. An electric kettle is used to boil some water. The mains supply voltage is 230 volts, so that's our V. The power supplied to the kettle is 1.9 kilowatts, so that's power, and we'd better put that into watts straight away, just in case we need it. Remember, 1 kilowatt equals 1,000 watts. Calculate the current in the kettle. Use the equation I equals P over V. So it gives us the equation and it even rearranges it for us, so we just need to pop the numbers in. 1,900 watts divided by 230 volts. And that comes out as 8.26. Part 2. A coffee machine takes 120 seconds to heat some water, so that's the time T. Mains supply voltage is 230 volts, that's our V. Current in the coffee machine equals 7.4 amps, that's our I. Calculate the energy transferred, so energy is our target, to the coffee machine in 120 seconds. Use an equation selected from the list of equations at the end of the paper. Right, so we've got E, I, T and V. So let's see what equation we've got. Well, there we are. E equals I, V, T. So energy transferred equals current times by potential difference times by time. I like to say Emmerdale is on ITV. So the current, just pop the numbers in. 7.4 amps times by 120 seconds times by 230 volts, and that equals 204,240. Question B. Figure 7 shows the inside of a mains plug. The neutral wire is labelled. State the name of wire X and the name of wire Y. Right, wire X is the earth wire, that's the one that goes to the top pin, and wire Y is the live wire. State the name of component Z, that's the fuse. So remember, the live wire goes to the fuse. If they ask you for the colours, earth is yellow and green, live is brown, and the neutral would be blue. Watch this. Blue goes to the left and brown goes to the right. So that's how you can remember the colours. Part C. A transformer is used to connect a laptop computer to the mains electricity supply. The input voltage to the transformer is 230 volts. Right, there's a lot of numbers here. Let's have a look. Input current times by input voltage equals output current times by output voltage. Right. The output current from the transformer is that. The transformer has an output voltage of that. The transformer uses 100% efficient. So that means that this lot here is going to equal that lot there. Calculate the input current to the transformer. Right, let's just put some numbers in. So we've got the input voltage, that's 230 volts. And we've got the output current is 2.37. Output current is 2.37 amps, and we've got the output voltage. Output voltage is 19 volts, and we're looking for the input current. Yeah, input current. So I need to rearrange that. So if we divide both sides by 230, that'll cancel that out and it'll just leave the input current. And that equals 0.1957. Now the most they've done it to is 2 decimal places. So we'll round ours off to 2 decimal places. So that's 0.20. Question 4. This question is about energy changes. Figure 8 shows a water slide. A person travels from the top to the bottom of the water slide. The mass of the person is that, so M is that. The change in vertical height H is that. Gravitational field strength G is that. Calculate the change in gravitational potential energy for the person. Use the equation. So they gave us everything, and they have even very kindly told us what the letters were. So that's 72 was the mass, multiply that by gravity, which was 10 newtons per kilogram, and multiply that by the height, which was 7 meters. And that comes out as 5,040. And that'll be joules. Part 2. The person comes to rest after the end of the water slide. Explain what happens to the energy as the person comes to a rest after the end of the water slide. Let's just have another little look at that picture. Well, they're just going to splash into the water. So their kinetic energy is going to get transferred into sound energy and heat energy, and that'll go to the surroundings. It's always the same pattern. Kinetic energy gets transferred to heat and sound energy to the surroundings. Part B. Figure 9 shows a person pushing a box from the bottom of a slope to the top of the slope. Explain which one of the three distances shown in Figure 9 should be used to calculate the work done against the force of friction between the box and the slope. Right, so the person is pushing it that way, which means that friction will be acting in that way. To get the work done, it's the force times by the distance moved in the direction of the force. So you're moving it up that slope, so it'll be 6.3 meters. And I'm going to label that force friction. So I should get 1 mark for saying friction, I'll get 1 mark for saying the formula, and I'll get 1 mark for saying the actual distance. So I should definitely get the 2 marks. Question C. Calculate the kinetic energy. So kinetic energy is our target of a tennis ball travelling at 28 meters per second. So that's a velocity. The mass of the tennis ball is 58 grams. So that's our mass. But we need to do 58 grams divided by 1,000 to convert it into kilograms. So that'll be 0.058 kilograms. Right, they've been kind enough to give us the formula, and we don't even need to rearrange it. So that's a half times by the mass, 0.058 kilograms. If you've made a mistake, it's probably because you forgot to convert it into kilograms, and multiply it by 28. And remember, it's squared. That's another common mistake by students. They forget to square it. And remember to square the 28 first. So do 28 squared, times it by 0.058, and then times it by 0.5. And that comes out as 22.736 joules, because it's energy. And I'll just round it up to 22.7. Question 5. Figure 10 shows 2 different types of the same circuit component. So these are both the same thing. They're just different variations. So I'll tell you what they are straight away. It's a variable resistor. What's the name of the circuit component? Yeah, D, variable resistor. So this thing, you turn the dial and it varies the resistance, and this thing, that's what we call a jockey, and you move the jockey backwards and forwards along this bar, and that changes the resistance. There's a load of resistance wire in this loop here. Which row in the table describes the way that ammeters and voltmeters should be connected with a component in a circuit? Well, an ammeter needs to be in series, so it's either this one or this one, but a voltmeter needs to be connected in parallel, so it must be this one. Your answer is C. Question C. Figure 11 shows the results from an experiment where the potential difference, which is voltage, across a filament lamp was varied. The current and voltage were measured. Describe the relationship between the current and the voltage as shown in the graph. Right, as voltage is getting bigger, the current is also getting bigger. And because it's a curve, we say it's non-linear. If it was a straight line, you would say it was linear. And if it was a straight line through the origin 0, 0, you'd say it was directly proportional. Part 2. Use the values of the voltage and current at point P and at point Q on the graph in figure 11 to complete the table in figure 12. Right. So at point P, the voltage is 1 and the current is 20. P, the voltage is 1 and the current was 20. And at point Q, barnacles. It's not perfect. Right, what's that? About 3.4, 3.5. And what's that? If that's 40 and that's 45, I'd say that's about 44. If you put your little annotations on the graph like I have, then the examiner will see what you've done and they might take pity on you if you get it wrong. So the voltage was 3.4 and the current was 44. Let's just double check I've got that round the right way. Current was 44, voltage was 3.4. That's the kind of thing that you'll make a mistake on. Okay, so always double check. Always best to double check. Part 3. Calculate the resistance of the filament lamp when the voltage is 4.5 volts, that's our voltage, and the current is 51 milliamps. Right, we're going to have to convert milliamps into amps. So do 51 divided by 1,000 and that'll tell us how many amps there are. So that'll be 0.051 amps. Pop the numbers in. So that's 4.5 volts divided by 0.051 amps. And that comes out as 88.235 ohms. And we'll just round it up to 1 decimal place. So 88.2. 4. Explain why the resistance of the filament lamp changes as the voltage across it increases. Right, so it's a filament lamp. As the voltage increases, you're going to have more current. And more current is going to make the filament heat up because you're going to have more collisions between the electrons and the ions in the wire. And that's going to make the resistance increase. So how do we say that then? As voltage increases, current increases. You get 1 mark for that. They've told you that the voltage is increasing, so you're not going to get any marks for saying voltage is increasing. That's why I've put that all in one line. So that's 1 mark for that. The temperature will increase. Right, in other words, the lamp gets hot. You're going to have increased collisions between the electrons and the ions. Now what I mean by that is if that's your wire, you've got all the little copper ions, the ions because they're positive, and you've got all these little negative electrons. Now, as the wire gets hot, these ions, these copper ions, are going to start vibrating more, and as they vibrate more, the little electrons that's trying to come down through the wire are going to get collided into more. And what that does is that increases the resistance, because resistance is just collisions between the electrons and the ions. Right, so you'll get 1 mark for that, 1 mark for that, 1 mark for saying increase of collisions, 1 mark for saying between the electrons and ions, and 1 mark for saying the resistance increases. So 1, 2, 3, 4, 5. So we'll definitely get 3 marks for that. Question 6. Describe in terms of particles 2 differences between a solid and a liquid of the same substance. So a solid is in nice neat rows. The particles are very close together. They just vibrate. They don't have much energy. Whereas a liquid, better put in a box, their particles are jumbled up and they're a little bit further apart. So there's loads of information there. Particles are in neat rows. Liquid, the particles are randomly arranged. Now sometimes they only give you 1 mark for saying either that or that. So let's put some more. Right, solid, the particles only vibrate, whereas here the particles can move. Solid, they've got less kinetic energy. Liquid, they've got more kinetic energy. Solid, the particles are closer together. Liquid, particles are further apart. And you can even say for a solid, high forces, that's because of the bonds. And with a liquid you get low forces between the particles. Now the reason why I've gave you so many there is because I've seen this worth 6 marks before. So there's easily enough information there to get the 6 marks. So I've just modelled the answer for you. Right, part B. Figure 13 shows the dimensions of a solid block of concrete. Density of concrete, that's the density symbol there, is 2,100 kilograms per metre cubed. Calculate the mass of the concrete block. Use the equation. Right, that's quite handy. They've even rearranged it for us, so we don't need to rearrange it. Right, so the density goes in, which is 2,100 kilograms per metre cubed, and we need to multiply that by the volume. Now the volume is going to be 1.5 metres times by 1 metre times by 0.2 metres. So that's the height times by the width times by the length. Now just be careful, because sometimes they can have one of these lengths or depth in centimetres and you'd have to convert it. Remember, there's 100 centimetres in a metre. So you'd have to divide it, if it was centimetres, by 100. And that comes out as exactly 630. And that'll be kilograms. So remember, this here was height times by width times by the length. Question C. Figure 14 shows a shed made mostly of concrete blocks. State 2 practical ways or to reduce heat loss from the shed. Right, so remember, you lose heat through the roof, through the walls, through the floor, through the door, and through the window. So, windows, how do you stop heat being lost there? Double glazing. Roof, sort of loft insulation, which is like fiberglass. Walls, you want cavity wall, which is basically a wall on the outside that we can see, then a gap, and then we usually use breeze blocks, which are big blocks. So the cavity would be this bit in the middle, which is a gap. Remember, if you've got a gap in your tooth, you've got a cavity, you go to see the dentist. Right, the door, you want a draft excluder. And the floor, you want carpet or foam underneath laminate flooring. Alright, so take your pick, whatever you want. I'm going to go for double glazing and draft excluder. And the last question, D, our 6 marker. The student has 2 metal strips and a ruler as shown in figure 15. Right, 2 metal strips and a ruler. A teacher tells the student that one metal strip is made of aluminium, the other metal strip is made of stainless steel. The student looks up data in a reference book, finding some density values. Right, density of aluminium is that, and the density of stainless steel is that. The student has access to more of the same metal strips if needed, and may ask for any extra measuring devices. Alright. Plan how the student could confirm the teacher's statements by determining the density of each of the strips as accurately as possible. Right, well, as I say to my students, base your explanation on the calculation. So they're talking about the density. Now, we don't know if this is aluminium or if this is aluminium. So if I find out the density, we'll know which one's which. And even we'll find out if it even is aluminium or steel. It might not be either of them. Right, so let's start by putting the formula for density. Density equals mass divided by volume. So what this does is it'll tell us what we need to measure. So we need to measure the mass of these bits of metal. Right, so what do you measure the mass with? So measure mass with a mass top pan balance. Right, we need to measure the volume. With what? Right, well, they're just uniform shapes. So we could use the ruler to measure the height times by the width times by the depth. And the volume is going to equal height times by width, or times by depth, or times by length, whatever. Now the thing is if these are skinny little metal strips, it says you can use more of the same metal strips if you want. So what you could actually do if you're going to use a ruler to measure that, it's going to be tiny. So you probably want to get a pile of them. So if we say get 10, and then we can divide it by 10. So use 10 strips and then divide by 10 to get thickness or the width. Or if you only wanted to measure one, you could use digital calipers. I know we haven't used them with my students, so it's just a very accurate way to measure it. It's like an accurate measurer. Accurate measurer. To get the volume, you could pop it into a displacement canister if you wanted to. So obviously the displacement canister, you fill it up with water, have a measuring cylinder here, and if you pop the metal into the water will come out here, and whatever the water is there, that'll be the volume displaced equals volume of the strip. Now they are saying as accurately as possible. So to get the mass, you might want to measure 5, or we'll say 10 strips. Measure 10 strips mass and divide by 10 to get mass of 1 strip. And then you'll need to compare your values for density with the density that the teacher said. So first of all, so calculate density by doing density equals mass over the volume, and then compare calculated value with teacher value to see if it was right, and then repeat with the other strip. Right, so you know what I mean, you can get a mark for that. I know I've put it down here as well, mind you. So so you get a mark for saying measure volume with what? With a ruler. How do you get the volume? I've gave the equation there. Measure the mass with what? With the top pan balance. To get it accurately, we've said use 10 strips if you wanted, but make sure you say divide by 10 if that's the case. Or you could say the displacement canister, you've said how to use it, and then compare it with the teacher value and repeat it. So you'll definitely get 6 marks for saying that. Loads of different things you can say. You say whichever one you think is the easiest for you to remember. And that's the end of that paper. So I hope that was useful for you. Make sure you watch and do as many of these past papers as you can. I'm telling you, they will make such a difference to you. Very best of luck in your exams. Work hard and be nice. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained.